What is up, mathletes? So today we're going to talk about solving literal equations. What? And before we dive into this is something that we all do, and this is something that is used in so many fields in the workforce, right? Whether it's nurses or people that have some type of accounting job or scientists, right? This is something that almost everybody has used, right? But what happens is a lot of people have their own techniques and their own ways of solving these type of equations. But if they know a process, if they understand this process, this would make their life so much easier. So here's a scenario, right? And again, this dates back, I'm sure we've all done this plenty of times and without even thinking about it. So here's an example. I'm bringing an example from my personal background. So check it out. So my example comes from this equation. So it says solve d, which is distance, equals r times t. So distance equals the rate at which you're traveling, or the object's traveling, times the time. How long has it been traveling? So my experience, I've been using this probably since I was 6, 7 years old, I don't know, is I remember my childhood going with my family to Disneyland, right? And we live about 8 hours away from Disneyland in California. And so I remember in the car kind of thinking, this is before Google Maps and Siri and all this stuff where we had computers just tell us, oh, it's about 7 hours away. You're about 6 hours away, right? I actually had to do math because I was anxious. When were we going to arrive? So I would look at how fast my dad was traveling because I knew, and then all right, he's traveling this amount of this speed, miles per hour. So in about 3 hours, we will travel this, and I'll look at the signs. Los Angeles, Anaheim, this many miles away, and I'll start to use this formula without even thinking about it, right? So there's a much easier way, right? Because again, I was taking some educated guesses, right? So what I'm going to show you today is how to solve these literal equations, right? Using some mathematical algebraic techniques. So let's start off slow here. All right, so here we go. D equals R and RT. And whenever the letters are stuck next to each other, we know that represents multiplication. And what I tell folks is when we're solving for whatever variable, whatever letter here, we're always doing the opposite. We want that letter by itself. So right now, the T is stuck to it using multiplication. So what's the opposite of multiplication? Bam, division. So we're gonna divide both sides by T because that is how we eliminate, right, that T from both sides. So now we have that R isolated. It's all by itself, right? Kind of like many of us.
I've been so lonely.
And on our left-hand side, we get D over T. So now we've solved for R. So when we're trying to find a rate, we know, oh, we just take the distance traveled divided by the time. And boom, right? So there's our first example. Let's dig a little deeper here. Example 2. Now, for this equation, again, you'll see these equations all over geometry. You'll see them all over the place. Okay, so here we have capital A equals little a, lowercase a plus lowercase b divided by 2. But this time we're solving for b. We're trying to isolate b by itself. All right, so here's my technique. And what's the beauty behind this is there's so many different ways of solving for b, but the only thing you have to understand is as long as you're using the correct mathematical properties, you could do whatever you want, right? As long as whatever move you make is what I call legal, a legal mathematical move, an algebraic move. So I don't like that 2 there, right? So what I tell folks is most likely you don't like fractions and they don't like you, right? So let's get rid of that 2. So we're gonna go ahead and we see we're dividing by 2. And what's opposite of dividing by 2? Perfect. We multiply by 2. So we get a 2 here, a 2 there, here a 2, there a 2, everywhere a 2, 2.
Just stop.
I'll stop. So you get 2a, 2 uppercase A, and that equals a plus b. But remember our goal, right? Our goal is to get b by itself. So since you have a plus b, the opposite of addition here, because we have a positive a, is we want to subtract a, right? And so remember, whatever you're doing, is it actually canceling? Because if it's not canceling, you better get your money back, all right? So we got b all by itself, and then we end up with 2 capital A minus lowercase a. So you ask yourself, is that b by itself? Bam, and you're done. So b is isolated. Not so bad, huh? Stick with me, you'll go places. Problem 3, solve for y, right? And notice, there's an x involved. So usually when you have an x, you always ask why. All right, anyways, solve for y. We want to get y by itself. So what we're gonna do, use your mathematical properties. What can you do, right? So what I like to do, let me rewrite this for let me rewrite this for the West Coast. All right, so what we're gonna do is we want the y by itself. So we want this group by itself, right? So that ax, it's gotta go. So we're gonna ax this to the other side. So we're gonna ax that to the other side. And notice it was a positive ax. So the opposite, the inverse operation of addition, right, is subtraction. So we're just moving it over. And again, you ask yourself, what did I have for lunch? But did these cancel? They did. So now you're left with by by Dr. Math. Don't forget to like, subscribe. Thank you. And that equals c minus 8x. Is that a timer going off in the background? My time is almost up, folks, so I better hurry. So we are solving for y. So b times y. What's the opposite of multiplying by y? That's right, it's dividing, right? Excuse me, what's the opposite of multiplying times b? It's dividing by b. So I divide my left-hand side by b, and whatever I do to one side, I do to the other side. So these b's cancel. So we're left with y equals c minus ax divided by b. And is y isolated? It is. So you are finished. Again, I don't want to sell you all these, you have to do this, then do this. Don't memorize things. Understand your rules of math, and then you get to be creative. Then you get to eat, sleep, matemáticas, right? For my physics folks, for my circuit folks, my engineering folks out there, this one's on you, right? Solve for R, right? A lot of people, this is what they have trouble with. Let Dr. Math take care of you. So what we do here is we have, oh wow, we have all these variables and they're in the denominator. So check this out. Whenever we have all these different variables, here's a secret, right? We're gonna find the LCD. So the LCD, right? The least common denominator is R sub 1, and R sub 2. And what we're gonna do here is we're gonna multiply every single one of these mother fractions by the LCD. You'll see what's about to happen. So check this out. I'm gonna take that 1 over R. I'm gonna take that 1 over R and I'm gonna blast it by the LCD. There's my LCD, right? Let me stretch. 1 and a 2 and a 3. All right, then I take the 1 over R sub 1, right? I'm gonna multiply that by the LCD and stretch, and a 1 and a 2. All right, so I get R1, sorry, R1, R2. I'm not sorry, the order doesn't matter. Plus 1 over R2, 1 over R2, R2D2. And we multiply that by the LCD. R times R sub 1 times R sub 2. Why did I do that? I don't know, my producers told me to. Shoot. So what's gonna happen is I am going to get to cross out whatever is the same on top and bottom, right? Bam, those R's cancel there. Nice. Here, the R1s cancel there. Double nice. These R2s cancel. Tell them what they want, Johnny. All right, so since all that cancellation took place, right, whole lot of canceling going on, you are left with R1 times R2, right? R2D2, and what it equals is R times R2, and you're probably noticing this guy had a little bit too much caffeine today, and then we have plus R times R1 because all that cancellation took place. And we're solving for R. So notice I have an R here and I got an R there. So whenever they both have R's, I could factor out that R. So let's get that factor out of here. So we're left with R1 times R2 equals R times, because we're factoring, and we got R2 plus R1. Now we're going beast mode in this problem, right? So notice we're trying to get the R by itself. So I have R times something. So let's go ahead and let's divide it by whatever we don't want. So we don't want that R2 plus R1. So we divide it by R2 plus R1. And what you're gonna notice is this cancels, and now you have solved for R. Thank you.
Thank you. You love me. You really love me.
So again, so many different ways of doing these problems, but what I want you to understand is know your algebraic properties. Know what you can and cannot do, and that's gonna take you far, my friends. Hopefully this was helpful. Don't forget to give us a like, subscribe, and I'm gonna go try to run a mile. Time to go. See ya.